Hello, I'm 𝗬𝗀𝗀𝗀𝗀𝗀. I'm a product manager for Azure Database for Postgres Flexible Server. In this Build 2026 session, I'll cover migrating workloads to Postgres on Azure. Migration tooling, it's in a phase of rapid improvement right now. The technology is more accessible. The cost is lower than it's ever been. I'll be looking at why we're seeing an increase in migration to Postgres, and also why on Azure. And then I'll be digging into the tooling that's available to help. So with that, let's take a look at the agenda. So I'll start with the why migrate. Then I'll take a quick look at some of the more recent features and Build 2026 announcements for Postgres on Azure. And then I'll go through the tooling that's available for migrating Postgres workloads to Azure. And after that, I'll look at how to migrate Oracle workloads, including like the schema, the database code, and apps to Azure. So with that, let's get started. And we'll start with the why. So this industry trend that we're seeing to consolidate database workloads to Postgres seems to be accelerating. There are multiple reasons for that. I mean, one, Postgres is it's a mature database service. It's got a highly optimized query engine. The extension model in Postgres is perfectly suited to adapt to any new technologies, whether it's the latest AI innovations or like industry-specific technologies like GIS. It's open source. It's backed by an independent community with no license fee, and that's really key. Cost is important, but what about migration to Postgres on Azure? Let's take a look at that. So we take open source Postgres, just as is, no changes, and run it as a managed service with all of the enterprise features needed to run critical workloads. We work with a lot of household names, just kind of showing a few here, but OpenAI is a good example. They're willing to bet their production workloads on managed Postgres running on Azure. And one of the reasons for this is we've been building the enterprise features that our customers are asking for. And as well as like enterprise fundamentals like performance, security, reliability, we're also paying a lot of attention to asks from the developer community. So we'll invest in features like the VS Code extension, the Azure AI extension, Microsoft Foundry integration. But you could still ask, why not just self-host on a VM? You could run a VM in Azure and host there, or host it with Kubernetes. So I really like to think about the full cost of ownership for a production workload. Now, there's an overhead to manage. You've got high availability, disaster recovery, you've got scalability, configuration, integration, security. Then there's compliance, there's maintenance updates, major version upgrades. I'm not going to read out every line of this. You'll be pleased to know. You're welcome to pause, but these are just some of the high-level points, and there's a lot more. So the key point is, if you're self-hosting and running in production, there's a cost to staying online and meeting all of these requirements. So let's just dig into that cost in another level of detail. There was a recent study by TechTarget that measured the before and after costs of self-managed versus running in Azure Database for Postgres. When you're hosting in a managed environment where you can scale compute and disk resources with features like built-in connection pooler, these companies were able to not just save costs, but also to get better application performance than when they were running on premises. So one other thing that I think is useful to call out is when Azure's hosting an open source database, it's not just about cost. We also have a responsibility to the community, to the upstream open source community. So I'll just touch on that a little bit. We have a team of Postgres committers. Now, they're independent. We don't tell them what to work on. They work on contributing to upstream open source Postgres. If we take Postgres 18, for example, some really significant features for things like query execution, async IO, observability, these were contributed by Microsoft committers. Now, it's great for Postgres, but it also means our customers, if they run into problems, we can reach out to the top experts in the world on these topics for help. So that's one area of investment. But another that's really important is we're investing in the developer experience for Postgres. Now, the VS Code Postgres extension, which is free to use, it's rapidly becoming a standard for Postgres developers. And it passed 500,000 downloads a few months ago. But it's not just a development environment. It's becoming more of a database operations platform. So you can deploy and manage Postgres. You can also do performance monitoring, troubleshooting, visualization. There are regular updates and there's continuous improvement on this. And I'll come back to this platform in the context of migration in a few minutes as well. So that's kind of the why migrate. Let's look at some of the new features and announcements that we've added. So we have a tech community blog. It's called Microsoft Blog for Postgres. And every month we recap the latest features that have been added. The community blog is a great resource for keeping up with our product and engineering teams. And it also really shows the pace of development because every month we've got a new set of features and we include guidance on where to look up more information and how to use them. I'm going to pick on one area in particular, which is performance and scale, and just take a quick look at some of the latest updates in that area. I'll start with a very recent announcement, Premium SSD v2. It was recently made generally available. It enables up to 80K IOPS, 1.2 GB per second throughput. It's ideal for I/O intensive workloads. What's nice is if you need more space, you can incrementally add it and only pay for what you need. You don't have to like double the size and pay for all of that. The graph on the right, it shows a PG bench test across 5 workload profiles ranging from 32 to 256 concurrent clients. As the concurrency increases, you see that SSD v1, which maxes out at 20K IOPS, it starts to max out as it reaches these limits. While SSD v2, it continues to scale, getting up to 4 times the transaction rate with sub-millisecond latency. Now, there's even more like a higher IOPS storage or a more powerful storage coming soon called UltraDisk, and I'll talk a little bit about that in the context of another new announcement, which is the Intel and AMD V6 compute SKUs are now generally available. So with these compute SKUs, you get up to 3 times the memory, double the vCores of V5. You also get better performance per core and better price performance. So these are based on the 5th gen Intel Xeon and the 4th gen AMD EPYC 9004. And with these, you will be able to get up to 400K IOPS if you use the V6 SKUs with the new high-performance UltraDisk storage option that's coming soon. So these features enable massive scale-up, but then there's also scaling out and parallelization to consider. So we'll take a quick look there. We recently made cascading read replicas generally available. So now a Postgres primary can replicate to read replicas, which can in turn replicate to another layer of read replicas. So if you need to scale out read-heavy workloads, you can have up to 30 replicas from one primary. It gives you more flexibility, and if you, for example, want to set up cross-region disaster recovery, you can have some of these replicas running in other regions. So this is how customers like OpenAI, for example, are able to have massive scale in their workloads. So that's scaling out read workloads. You can also scale out your data across multiple nodes. So one feature that it's been generally available for a while now, Elastic Clusters. It makes use of the Citus Postgres extension. Your app can talk to one Postgres endpoint, but you can also shard your data across multiple Postgres nodes. So this overcomes the storage and processing limits of a standalone server. And you can shard by rows or you can shard by schema, depending on whether you want to make application changes or not and the level of parallelization that you want. So this can lead to massive performance improvements. And this feature, when it comes to managed Postgres, this feature is unique to Postgres on Azure, and it really unlocks scale. It's tried and tested too. Behind the scenes, it's powering other services at Microsoft. And in terms of recent announcements, we recently added Postgres 18 and major version upgrade support. So that's kind of some of the big performance and scale new features. What else are we announcing at Build 2026? There's a lot of new announcements. I'll mention a few of them here. I've divided them into a few categories here: migrate, maintain, monitor, build. So for migrate, I'm going to go deeper into the AI-assisted migration features. Also, Azure Migrate, the Azure Migrate tool has added Postgres server discovery and made some improvements there. So that really helps with the first phase of migration, which is, what do I have? What do I need to migrate? And then under maintain, a managed service, it needs maintenance. For example, applying minor version updates to Postgres or security patches to the container OS. We've added some features to increase your control over when maintenance is applied. So now you can defer a maintenance update for up to 2 weeks. And you can also apply an update on demand instead of waiting for a predefined window. So this is really useful to just get that control to apply a maintenance update when it doesn't inconvenience a production workload. And then for major version upgrades, we've added a pre-upgrade validation check, or we've extended the pre-upgrade validation check. So you can simulate an upgrade, fix any issues before applying an upgrade. And the goal here is an upgrade that works with no surprises. Under monitoring, you may have seen there's a new Grafana dashboard option for Postgres available in the Azure portal. These Grafana dashboards, they make monitoring your workload a lot easier and customizable. Or if you run your analytics and reporting in Microsoft Fabric, then you can mirror your data from Postgres for free. And we've added support for more scenarios like empty tables, more DDL, data definition language operations, and to make it more robust. And then we've also added Defender security assessments, so you can audit the security posture for your database. For example, does my database have public access? Does it have public schema access, public role access that needs locking down? Or does it have the recommended PG audit settings? And then in the category of building apps, there's a bunch of improvements that have been made to the VS Code Postgres extension. So an example is query plan visualization. There's an enhanced performance dashboard, so you can work with the query store to troubleshoot your top queries. We've added more operations as well, like backup and restore. And I'm going to include a few links at the end to some build sessions where you can see some of these new features as well. And also linking to another area, which is the high-performance Horizon DB service that's in preview. Let's get on to migration then. And let's say you have a Postgres workload. Maybe you're running it on premises, you're running it in a VM. Let's take a look at the tooling that's available to move it to Azure. Now, whether you're bringing your workload, wherever you're bringing your workload from, we have a migration service that moves it in one step. So you could be running in a VM. We've also got support for a bunch of other services where you could be running Postgres. And in fact, we've also recently added EDB and Huawei as sources as well. So with the migration service in Azure Database for Postgres, you can just point it to the endpoint of your source and move it. You can migrate online to minimize downtime, or you can do an offline migration that has fewer limitations and a very easy setup. You can also do things like flexible server to flexible server migration. It's not like officially a supported option, but it works and it gets you around. Like it can be useful for certain configuration changes that might have otherwise required a point-in-time restore. So how do you actually get to it? Let's take a quick look at that. You can run the migration service from the Azure portal or on the command line with Azure CLI. if you're using the portal, the best way to reach it is to create a new flexible server and then select the migration option. So I've included that in this little screenshot here. From there, you can select your source, and it takes you step by step, as well as listing the prerequisites that you need to follow. Now, the list of checks there, worth paying a lot of attention to, and it also links through to docs and tutorials to help you with these steps. If you're using the command line, CLI has full support built in. If you do run into limitations, there are also options to use things like the open source pgdump and restore. I'll include a link to scenarios where you may want to do this as well at the end. So that's Postgres to Postgres migration, very straightforward. Let's look at something more complex, like migrating Oracle workloads to Postgres on Azure. I touched on some of the reasons people want to do this. Perhaps the number one reason that we see a big rise in Oracle to Postgres migrations is license cost. Now, I'm showing a list price example here of a license cost for a 16 processor license. Maybe you'll get a discount, but if you compare it to the Postgres license cost of 0, there's a really compelling reason to look into migration. The only caveat which has stopped a lot of people from migrating in the past is that cross-database migration has always been complex and therefore costly. If you divide the migration journey into phases, it starts with discovery and assessment. But the most challenging, complex phases are really, for migration, really migrating the database schema, migrating the database code, like store procedures, packages, triggers, etc. Migrating the application. Maybe you've got a Spring Boot or like Hibernate app or .NET, Python, etc. And then, of course, migrating the data as well. So these 4 phases are typically where we work with customers on. And then, of course, once you get your database into Postgres on Azure, there's a lot of performance tuning and cloud optimization options that you can then take advantage of. So particularly the first 3 steps of these complex areas like schema, database code, and application migration, this is where we've added our own tooling to help reduce the complexity and lower the cost of these steps. So what's the tooling? So the AI-assisted Oracle to Postgres migration tool, it's available now in the VS Code Postgres extension. It takes care of the Oracle schema, database code, and application code phases of the migration. I've included a short link here you can go directly to more details. So with that, let's take a look into how it works. We'll start with the schema conversion. So the migration tool starts by extracting the Oracle schema and then groups it into related objects. It uses an LLM to create related chunks and then deploys a set of schema conversion agents which interact with the LLM, and they create the SQL code for Postgres. They validate the code and then make further changes and iterative improvements. So the final schema output is then available to review, and also notes from this phase are available for the AI tooling to use in the code conversion phases as well. So let's take a look at this in action. I'm going to show a schema migration demo that's recorded by Jonathan Frost, who's one of the program managers who worked on this feature.
Hi there, this is Jonathan Frost from the Azure Postgres team, and in this demo I will demonstrate the Oracle to Postgres migration experience. To begin our migration journey, we'll create a new migration project using the Postgres extension and provide a name for the project. Next, we'll connect to an Oracle server by providing connection parameters. In this case, we are connecting to an instance of Oracle version 19c. I can list schemas available on the Oracle server and select the one or more I want to connect to Postgres. Now, I'll configure the Scratch Postgres database. The Scratch database is used to test each converted schema object and automatically fix discovered issues. The agentic self-correction approach using this live Postgres database significantly improves reliability of the migration process. The last step of the configuration process is connecting to an Azure OpenAI endpoint. This endpoint is used in combination with agent mode to scale migration to thousands of objects, something Copilot agent mode cannot do out of the box. Now that we have created a migration project, I will go ahead and click the Migrate button to start the extraction and conversion process. The first stage is extracting the Oracle DDL, which is indicated by this top progress bar. The second stage is converting each chunk of DDL via the multi-agent orchestration workflow. At this point, the chunk was attempted to be compiled against the Postgres database. And at this point, some errors occurred in the compilation. In the following step, the conversion agent took this into account and reconverted this chunk of DDL and recompiled it against the Postgres scratch database. Lastly, the status updates show the compilation was successful and the chunk was applied to the Postgres database. Additionally, we can see 2 coding notes were captured. Coding notes are context items that may be helpful to an application migration, and our additional application conversion tooling brings these into the process. Here, we see a comprehensive migration report is generated and shows the details of the number of objects converted, object types, and the Postgres extensions detected and used for the conversion context. This test conversion only processed 34 objects. We have had customers successfully test this on a scale of over 2,000 objects. Now that everything has been converted, we can use our Postgres extension Visualize Schema feature to quickly validate the tables and relationships now in the Postgres database. This looks good. Next, let's review the converted DDL. To do this, let's right-click on the addresses table and compare the Oracle version and the generated Postgres version side by side. All right, this also looks good. Now let's go back to the migration project wizard. After this initial conversion is done, we can enter interactive mode. For every conversion issue that was discovered and couldn't be resolved automatically, the tool has created a follow-up task for the developer. You can see here, in this table, we have a handful of tasks to review. Let's work on this complex trigger one together. I will click the Run Task button to help me with this task. The migration tool has generated a custom prompt for me that gives all the context to the agent mode and enables it to suggest a solution for the issue. Agent mode was able to recognize the issue and provide a correction. Let's have a look at the 2 files that were modified. These look good. We can keep the changes and finalize the migration. In this demo, we were able to connect to an Oracle database and convert its schema into the Postgres format. We were able to perform it at scale and then track and resolve complex migration issues in interactive mode.
So that's schema conversion. Now for application conversion, you'll be creating a VS Code workspace migration project and copy the application files locally. The VS Code extension leverages GitHub Copilot agent mode. It uses a Claude model with custom conversion blueprints and report templates from the schema conversion phase. The agents are using LMTs, or large language model-based translation layers, to convert the code, queries, and application logic across the technology stacks. It also uses an Azure Database for Postgres instance to validate versions and extensions as it goes along. So with that, let's take a look at that in action. So I'll play another demo from Jonathan. It's a shorter demo that covers the moving a Java application.
Hi there, this is Jonathan Frost from the Azure Postgres team, and in this demo, I will demonstrate the Oracle-to-Postgres application code migration experience. We have already created an Oracle database schema conversion project. Now we continue on our journey to the next step of the wizard, application conversion. I will click Convert Application to start the process. I will select the location of the application codebase and the connection to a Postgres database instance to provide database context to the application conversion. In this case, I have a copy of the codebase already in the root of my VS Code workspace, which I am selecting. This starts a composite prompt, which invokes a custom language model tool, or LMT, for converting the Oracle client application code to Postgres equivalents using the target Postgres database context. You will see here and here, we are connecting to our chosen Postgres database. Then at these points, our additional LMTs are obtaining the version and installed extensions of the Postgres database. Here, you will see our coding notes are being read from our recent database schema migration. These provide valuable context to the application conversion flow. At this point, you can see that it's making resource and database connection changes to the codebase. Now it is changing the ORM code to align to the models of the Postgres table data types. Now, at this point, we are calling the build Java project LMT. This LMT is provided from the Java app mod extension. By referencing this LMT in our blueprints, we can leverage capabilities across our related extensions. The build process runs and looks like it was successful on the first try. In the next step, we call into the generate unit tests LMT. This is another LMT provided by the Java app mod extension and provides a powerful capability to extend our conversion experience. Now that the unit tests are completed, you can see it successfully generated and ran over 30 tests with a 100% passing rate. Not bad. For a final step in the application migration experience, a comprehensive report is generated and opened automatically for the user when the flow completes. In this demo, we were able to convert an Oracle client application codebase to the Postgres equivalents. We performed this process with a combination of custom LMTs for code conversion and database context. We detected this was a Java app, and when we leveraged the Java app mod extension LMTs to provide enhanced capabilities across our installed extensions.
Okay, so let's do a quick recap. We looked at some of the reasons behind the industry trend to consolidate database workloads on Postgres. We looked at why Postgres on Azure, and then I went through some of the latest performance and scale features and also build 2026 announcements. Then we looked at migration tooling for Postgres-to-Postgres migration and the AI-assisted tooling for Oracle-to-Postgres on Azure. There's a lot of information there, and I'll add some next steps to find out more. So here are some links to Build 2026 sessions. Some of these, like the lightning talk, for example, are only available at Build, and others are available online. So I've included a short link here, aka.ms Postgres on Azure Build 2026. You can go there and see the links to the sessions. So with that, one other thing I've added is some links to the Postgres documentation as well on migration and migration tools. So with that, I'll leave it there, and thank you for watching.